So the big picture for this lesson is translations. A translation is a rigid motion. So a translation moves points of a figure the same distance in the same direction. And vectors can be used to describe translations because they indicate the direction of the translation and also how far the translation is. So basically, if you can take a shape and use a vector to move the vertices, then you can just translate the rest of the points the same way. So you can see points A, B, and C translate to points A prime, B prime, and C prime along this vector V, which is from E to F. So everything moves according to that vector. That's a translation. You can make your own translation using some tracing paper, draw a triangle using a dark marker, and then draw a vector. And then on tracing paper, you trace the triangle and the vector, and then you just put the vectors tip to tip, and that creates the transformation that you see here, which is a translation of triangle ABC along vector EF. Parallel lines are defined as distinct lines lying in the same plane that never intersect. They also have the same slope. And parallel lines are important because when you're translating, the translations go along parallel lines, and also if lines are parallel before a translation, they're also parallel after a translation. So here's what I was talking about. Point P translates to point P prime, and that's along vector V, and this translation here is parallel to the vector V. So vectors can be written in component form, and the component form shows the x value of the vector and the y value of the vector. And that makes translations very easy on the coordinate plane because you can just apply those transformations according to that component form. So in this example, the vector is 4, -3 in component form, and then you can also write it in coordinate notation that xy translates to x plus 4 and y minus 3. Those are the same. If you're given a transformation, you can find the distance of the transformation using the Pythagorean theorem. Just pick a point's pre-image and image, and then use the Pythagorean theorem to find out how far. And so it was found the component form or vector form was -6, 6, and then you can just use that for the Pythagorean theorem, and it solves for 6 square root 2 or about 8.5. So that's what you're going to be doing in this lesson. You're going to deal with vectors, translations, and that's the big picture.